In this video lecture, we'll return to our earlier discussion about the general problem-solving thought process and now see how it applies specifically to writing software methods. Okay, let's get started. In an earlier lecture module, we discussed a standard three-step problem-solving thought process. Just by way of refresher, the steps are these. What do I already know, or what am I given? These are my knowns. What am I trying to find out or solve for? These are my unknowns, or the desired result or solution. And finally, for the meat of the problem, how do I transform what I know into what I'm looking for? How do I solve my problem? Or more informally, how do I get from point A to point B? We already saw how this standard three-step problem-solving process can be translated into simple sequential logic programs, similar to the simple programs we've probably recently written. In fact, we also showed how this process can be captured in our program template. Now we'd like to show how that three-step problem-solving process is equally applicable to software methods, which are nothing more than named, reusable sets of program instructions. Similar to what we saw previously, the same problem-solving thought process applies equally now to methods, but again with the second and third steps sort of swapped. First, we'd again ask ourselves, what are our knowns, or now our computational inputs? For methods, these are now passed in via the method interface, which is the opening line of any method. In addition, we might also need to declare and initialize some local variables or constants as well. Then again, in the middle step, or the guts of our program, we would transform what we know into what we are looking for, or our unknowns, by using some algorithm, which again is just some logical sequential progression of steps. Here, this set of steps comprises most of the internals of our method, which we call the method body, or method implementation. Finally, as always, we'll want to do something with our computed outputs. For a method, typically that means that we want to return some value to the calling program or client. The client, of course, is just some outside code which uses or calls our method. The data type of whatever value we return is specified as part of the method interface, and our return variable or object must be of that specified data type. This standard problem-solving sequence for a method is embodied in the general code structure of any method. Our method interface specifies our known inputs, or the things that can change between any method calls. Our method implementation, or method body, represents our calculations, the operations which are the same each time and are applied to the specified inputs which can vary. Finally, a return statement at the end of our method is how output values are returned to any calling client. If all this seems kind of abstract at this point, let's make it a bit more concrete by seeing what it looks like in code. Here's another visual mapping of the three-step general problem-solving process on the left, this time to the corresponding sections of a general method template on the right. This time, the "What do I know" step is represented by the method interface on the right. Inside these parentheses will be any method inputs, which consist of data type variable name pairs. These represent the input data which can change every time this method gets called. As noted in these first two pseudocode comments, we might also need to set up some local variables or constants in order to solve the problem. The middle part of this method is again the guts of this method. This is where we transform the method inputs into the desired outputs using some TBD computations, algorithms, or equations. We often refer to this as the method body, or the method implementation. These are the statements which are the same for any inputs we might provide. Finally, the last statement of any method is typically some sort of return statement. This is where we do something with the results of our prior calculations. In this case, we are returning our results to some calling program. Note that the data type of any return value must match the return data type specified up here in the method interface. So for example, if we specify that this method will return some double value, we need to make sure that we are indeed returning a double value down here. As we mentioned previously, notice the swapping of steps when we're mapping this problem-solving thought process on the left into a generic method structure. But it's still all the same three steps. So summarizing, these are our inputs, the data which changes. The computations of the method body are the actions which are the same for any inputs, and the output is our return value here, which must match what we specified up here in the method interface for the return type. This may be a simple, trivial method, but it still shows all the steps of our general problem-solving process. Let's now see how we would put this method to use. To wrap things up, here's a side-by-side view of the method body versus a corresponding external client method call. We just finished looking at the method body on the left side. This is simply the internal details of how the method transforms its provided inputs into its outputs. Here on the right side, this method call demonstrates the external usage of the method by some outside client program. All we're doing here is simply providing the method with whatever data it's expecting to receive. On the left side, the method interface tells us it's expecting as inputs an int quantity of something and a double unit price for that something. So any place we try to call that method, as seen on the right, we provide this method name with an int value and a double value, which we've set up beforehand. Back on the left-hand side, we see that this method is going to return to us some double data type result, which back on the right-hand side simply means that this entire method call expression will evaluate to one single double value, which we can assign back to some declared double variable. And that's all there is to it. This method call on the right carries out this set of instructions on the left, using these two input values. Finally, note that the variable names we use can differ on both sides, and this is pretty typical. As long as the method receives two pieces of data of the specified data types, here an int and a double, the code and the compiler are both happy. You'll probably be writing some simple methods like these in a current program assignment. Okay, that should do it on the problem-solving structure of methods.